Hello everyone, welcome to CCSK Domain 1 video. So, cloud computing. As per NIST, the cloud computing is a model for enabling the ubiquitous, convenient, on-demand network service to a shared pool of configurable computing resources. For example, the networks, servers, storage, applications, and services that can be rapidly provisioned and released automatically without requiring any management effort or any service provider interactions. This is the definition as per NIST, but you can be tested in the exam that ISO can say the paradigm for enabling the network access to a scalable and elastic pool of shareable physical or virtual resources with the self-service provisioning and administration on demand. So these are all terminologies here. These can be these are the important characteristics of the cloud, on-demand network access, self-services, scalable and elastic pool of shareable resources on demand. So these are all important characteristics of the cloud. There are some cloud actors which CCSK talks about. So throughout in every domain in CCSK, these cloud actors will be used interchangeably. For example, the cloud user, cloud customers, cloud consumer, or cloud client. It is the same thing. It is a person or the organization requesting and using the resources. Sometimes we call them as customers, sometimes we may call them as users or consumers or the client. While the cloud provider and cloud service provider, the CSP, throughout the CCSK domains, we will be using these terminologies. It is somebody who is providing the services, delivering the services to the customers, to the users. Cloud aspects, uh, two key techniques to create the cloud. One is the abstraction. It is basically the resources from, the abstraction of the resources from any underlying physical infrastructure to create any pool and use the orchestration. The orchestration is basically to automate all the resources for provisioning and deprovisioning of those resources without without requiring any human intervention or manual intervention there. The cloud versus traditional virtualization, the important aspect is the virtualization that abstracts all the resources, but it typically lacks the orchestration. So there is no orchestration in the traditional virtualization. Uh, it delivers them to the customers on demand, instead relying on the manual processes. The clouds are multi-tenant by nature. Of course, the multi-tenancy is when when the services are being used by the multiple different consumers, and they are sharing the same pool of resources. But the important point here to note is these resources are segregated and isolated from each other. That is the most important aspect here, most security aspect. Uh, Segregation allows the cloud provider to develop resources to the different groups, while the isolation ensures that they cannot see or modify each other's assets. Assets could be information, data, or any execution environment, etc. These are the cloud essential characteristics as per NIST. So these are the 5 important characteristics defined. Resource pooling. Um, it is basically the abstraction of the resources that collects them into a pool. portion of which can be allocated to the different consumers depending on the policies defined by the provider. Uh, while the on-demand self-service, it is that something the customer can manage on their own. They can use any service on demand. If they need any resource, they don't need to talk to the human administrator anywhere, and they can just use these resources as per their demand. If the demand is increasing, they can increase the workload and they can increase the resources to accommodate that demand. Broad access network, it means that all the resources available over the network without any need for the direct physical access. You don't need to visit the data center to access any resources. Everything is available on the network. Rapid elasticity, it means the consumers can expand the resources they use from the pool. They can provision, they can deprovision automatically. There is no manual intervention required. It is the automatically based on the demand. This allows them to more closely match the resource consumption with the demand. Measured service, it is a meter basically. You just need to pay whatever you are using. For example, you are using the cloud services during your working day, and the moment you're done for your day, you just go and shut down those services and leave for the day. You don't need to run those services unnecessarily over the night, and you don't need to pay for the idle resources. Multi-tenancy is the sixth essential characteristic, but not as per NIST. Multi-tenancy is the sixth characteristic only as per ISO. So you may be tested that as per NIST, these are the five. Which one is the sixth as per ISO? Cloud service models. So these are the different service models in cloud. Sometimes we known as these are known as SPI tier. IaaS, infrastructure as a service. For example, you need a compute service, you need a workload, you need network services and the storage services. This falls under the category of infrastructure as services. PaaS, platform as a service. This is a database and the application platforms. For example, if you want to develop your application on the Linux, then you need Linux platform. You don't need to develop your virtual machine, or you need to make your own physical machine in your infrastructure. You just go and ask for a particular platform, and you start doing the development. SaaS is software as a services. This is the ready-made solution. You don't need to do anything. It's just the data that you need to take care of. For example, the Google Excel that you use, it is a SaaS. You don't need to do anything, right? You don't need to install anything. You just start using the Google Excel and start using that. Cloud deployment model here, um, there are four different models: public, private, community, and hybrid deployment model in the cloud. um, but what is managed by whom, what is owned by whom, and located where, and who all can access and consume those services? This is elaborated clearly here. For example, the public deployment, it is the infrastructure managed by the third party provider. It is owned by third party provider, and it is nowhere on premise. It is off premise in the cloud completely. And the access is actually untrusted because this is in the public cloud. While in the private and community, infrastructure can be managed either by individual organization or can be managed by third party provider, or vice versa. And similarly, the owner of the infrastructure has to be either organization or third party provider. And we just need to take care of that. If the infrastructure is managed by organization, then can be owned by third party, you know, something like that, and can be on premise or something like that, right? So different combinations here. Similarly, the infrastructure located on premise as well as off premise, um, the access is trustable. This is only trusted. Sometimes it is on premise. Sometimes it may be on premise, off premise. Fourth one is the hybrid deployment model, where both the organization and the third party providers managing the infrastructure, and on the ownership lies with both organization as well as the third party provider. The infrastructure location is actually both. It is a mixed in the hybrid model, on-premise as well as off-premise, because some services are running on-premise and some services are running in the cloud, purely in the cloud. So some services which are highly sensitive, these are supposed to run in on-premise. These cannot be pushed to the cloud. And the accessible, it is accessible, trusted and untrusted. Logical model, it is where the infrastructure, meta structure, appli structure, and infrastructure. The meta structure is something which is, making the ultimate difference between the traditional infrastructure and the cloud infrastructure. Infrastructure is responsible for compute, network, and storage, while the meta structure is this is the key differentiator, by the way, from the traditional IT. Protocol and mechanisms that provides the interface between key infrastructure layer and the other layers. So basically, what all infrastructure is required by whom, and this is all configurable in the meta structure. This is managed by the management backplane, and this needs to be keep secure. This is very important. Appli structure is this is something deployed in the cloud and underlying application services used to build them. For example, platform as a services. Infrastructure is data and information. For example, any content which is in the database or in the file, we need to protect that. So for infrastructure, we need data security. The information need to be secure. Appli structure, we need to adhere to the application security guidelines and implement and protect the application layer and the pass. The infrastructure and the meta structure needs to be take care using the infrastructure security guidelines. Cloud security responsibilities. Sorry. So there are different responsibilities while we have like physical security. So first of all, we have infrastructure as a security, we have platform as a security, and we have software as a security. Okay, and starting from the lowest layer, from the physical to the top, it is the physical security means data center, where it is located, how it is made secure. Infrastructure security means how the servers are made secure, deployments in the VMs and all that, and the OS level security, application level security, data security, and then it comes to the GRC. GRC is something, it is the overall responsibility of the customer, not the cloud service provider. So GRC is related to the policies, risk, and the compliance. For example, if the customer is storing the health-related data in USA, then probably they will need to comply with HIPAA compliance, and accordingly they need to manage with the risks, and accordingly they need to frame the policies as part of the governance. Okay, so let's talk about the physical security. It is the full responsibility of the cloud provider. Okay, while in the infrastructure security, in case of IaaS, it is um, it is this shared responsibility, while while in case of PaaS and SaaS, it is purely the cloud provider's responsibility. While for the platform security, it is customer's responsibility alone. Um, in case of PaaS, it is a shared responsibility of the customer as well as the cloud provider. While in case of SaaS, it is purely the cloud provider's responsibility to manage the security. Application security, of course, this is being developed by the customer and deployed by the customer. So deployment at IaaS and development at PaaS, it has to be the responsibility purely of the cloud customer. While at the SaaS level, it is a shared responsibility of customer as well as the cloud provider. Data security, because this is the data of the customer, then at each service model, in infrastructure as a service, platform as a service, or software as a service, it is purely the responsibility of cloud customer to manage that. Similarly, the GRC, policies, manage risk, and managing with the compliance, because it depends what kind of data it is, and what all standards, what all regulations that the customer need to comply. So it is purely the customer dependent. So need to maintain the security at each service model, IaaS, PaaS, and SaaS. It is the cloud customer's responsibility. It has nothing to do with the cloud provider. CSA Security Tools. There are two talks that CSA talks about. One is the Cloud Control Matrix (CCM). It lists down all the cloud security controls and maps them to the multiple security controls and the compliance standards. Different security controls and maps them with the different regulations and for the different service models, for the different cloud deployments. We will not talk about here in details about the CCM. I'll take another session, or we'll prepare the video for CCM specific. Uh, CAIQ, this is Consensus Assessment Initiative Questionnaire Tool from CSA. It is basically to perform the assessment of their own cloud offerings, and the provider is supposed to do the assessment here. They need to do the assessment using CIK tool, and accordingly they need to submit it to the CSA star registry for the further level of the attestations. There are different star levels here. One is star level 1, star level 2, and star level 3. So star level 1 is the self-assessment. There is no third-party audit involved. The cloud provider is supposed to use CAIQ and perform the self-assessment and submit it to the CSA star registry. For star level 2, this is supposed to be done by third party, or we can call it as um, we call this as star attestation. Um, this is to be done by the third party certification authorities, or the audits, we can say. Whatever controls are implemented in the cloud, these needs to be assessed and to be audited by the third party for the certification purpose. Star level 3, it is for the continuous auditing. This level is just a placeholder for now. It has no concrete definition as yet. Cloud security model. It is first to identify the requirements, then select the service model and deployment model. So why we need to identify the security requirement first, and then we move to the provider? Because first of all, we need to check what we want to achieve, whether we want to do the CSA star level 1 or 2, and what kind of information we want to store, what kind of what kind of regulations we need to adhere to, what kind of compliance we want to achieve, and then we need to select the provider, and then we need to choose the service model and then deployment model. We define the architecture as the next step, and we assess the security controls, and then we identify the control gaps. So the key here is to identify the requirements, design the architecture, and then identify the gaps based on the capabilities of the cloud platform. That's why you need to know the cloud provider and architecture before you start translating the requirements into the controls. That's the key. And then you start designing and implementing the controls. Manage the changes, whatever changes that we are doing in the cloud deployment or the cloud applications. We need to manage those changes through some predefined policies and some tools. Okay, so this is it for CCSK Domain 1. Thank you. Please subscribe and stay tuned for Domain 2 video. Thank you.